Hi everyone, we're starting video 10 on solving linear inequalities, so we'll be reviewing that along with defining feasible regions and constraints. So what we're going to look at right now is we're just going to review very quickly what we've already done. What we've done in the last several days is we have graphed inequalities, and once we have graphed those, we have shaded in the appropriate regions, and then we've looked at where these shaded regions are overlapping when given more than one or two graphs. And we said that the area where all the graphs overlap once they have been shaded in, we said that up until now I said that all they did was they were the area that satisfied all three of the inequalities. And what that meant was no matter what point I pick inside that shaded region, so whether I pick like an XY value that's inside the shaded region, it should satisfy all three or all of the inequalities so that it makes all of the inequalities true. Okay, so let's take a look at an example here. So we've got three equations that are inequalities that I have graphed. So y is greater than or equal to 1/2 x plus 2, y is less than or equal to 4, and y is greater than or equal to negative x plus 3. Alright, now all three of those were graphed, and instead of showing all of the shaded regions, which just made it a mess, all I did was I colored in the section that was the shaded region, or the area that was the region that was common to all of them that was shaded in. And it happens to be this yellow region right here, right now. Alright, so that area where all three graphs in this particular case, okay, that there's three graphs, because the area that's being shaded in that's common to all three of them is that yellow triangle right there, that's called the feasible region. And that's the region that represents all the given constraints. Okay, so what are the constraints? The constraints are the actual inequalities. So when we're saying, well, y has to be bigger or equal to 1/2 x plus 2, or y has to be less than or equal to 4, or y has to be greater than or equal to negative x plus 3, those are the constraints that I am giving. That is, those are the limits that I am giving of what the graphs can look like and where they should be. And from there, we are determining the area or the shaded in portion that's common to all three of them. So when I mention that the feasible region is the yellow region in this case, that yellow region is referring to the area is referring to all the coordinates in that small triangle in the yellow section. So all of the coordinates that would be in that small triangle, they will satisfy those three inequalities. So for example, if I chose the point 1 and 6, for example, the point 1 and 6 would be out here somewhere that I'm coloring in black. And because it's not inside the feasible region, it's not in the area that is shaded in, then I know that it's not within the feasible region. So I know that that point 1 and 6 does not satisfy all three of the given inequalities, which are the ones here on the left in green, blue, and red. Okay, so having said that, let's move on. And we're still using the same example as on the previous page. We're just continuing to build on that example. And we have what's called the corner point principle. So I have again the same area that has been shaded in, and we notice that there are 3 points that form the triangle. We see a triangle forming here where the 3 points are. Those 3 points on the in the triangle are the corner points. And the corner point principle basically says that in the feasible region, the best results, or the maximum, or the best solution is always going to be found at a corner point of the regions. So in other words, I could choose points that are inside in the shaded area. However, they're not going to be the best points or the best solutions, which either maximize profit and so forth, because they're not one of the corner points. And what the corner point principle is saying is that in order for there to be the best solution, okay, to a feasible region, well, that best solution will always be found at the corner point, so at a corner. All right, so In this particular case, we can see two of them very clearly. Two of the points are found at -1 and 4, the other one is found at 4, 4, and the third one is found at 2/3 and 7/3. Now, how was that third point found, the one at 2/3 and 7/3? Well, because I can't read it right off of the graph, 2/3 and 7/3, that means that I must have used another means or another method. So what I do is I take a look at my graphs, and I say, well, I have the red graph that's crossing with the green graph right here. So it's y is greater than or equal to -x plus 3, and 1/2 x plus 2 is the other graph, the green graph, where they are crossing each other or where they are intersecting. Okay, so what I'm doing is I'm finding the point of intersection of those two graphs, because that's what forms my third corner point. So what I do is I say, well, y is greater than or equal to 1/2 x plus 2, and I take y is greater than or equal to -x plus 3, and because when I'm looking at solving for the point of intersection, I'm always dealing with equations, it's really irrelevant for me to have inequalities. So I could just change this directly to y equals 1/2 x plus 2, and y is equal to -x plus 3. And what I'm going to do from there is I am going to very quickly find the point of intersection, and I'll do that by using systems of equations. In this case, I would rather prefer to use the substitution method, because the two equations are already isolated. You've already got y isolated for both equations. So that I will insert, or I will substitute, y equals -x plus 3 in y is equal to 1/2 x plus 2. So that I will say -x plus 3 is equal to 1/2 x plus 2, and then I will isolate for x. And when I isolate for x, just to hurry up, I know that x is going to be equal to 2/3. So you can figure that out on your own if you want. You can just do that very quickly. I just isolated for x. And then all I did was I substituted x equals 2/3 into either equation. So I'm going to pick the easier one. So it'll be y is equal to -x plus 3. And when I do y is equal to -2/3 plus 3, my solution here goes to y equals 7/3. So what that tells me is that the third corner point then is going to be found at x equaling 2/3, which we just figured out from up here. Okay, it's up here, the 2/3, and my y value is equal to 7/3. So I'm done. Okay, now once we've got the 4 corner points, okay, we're carrying this problem on to higher levels. So what you're given now is you're given what's called linear programming. And linear programming is nothing more than just finding the method of finding the best solution for a feasible region. So your goal is to either find the triangle or a rectangle, so a triangle with 3 points or a rectangle with 4 points of some sort of quadrilateral. Okay, and you're going to find all 4 of the points, because remember we said the best solutions are found at the corners. So you could be looking at 3 points if you've got a triangle that's formed, or you could be looking at 4 points if it is a quadrilateral that's formed. And what you're given now is, let's see in the problem, it says, if the profit function p equals 20x plus 30y is to be maximized, so that means I want the highest possible profit under the constraints, so given the constraints that were the green, blue, and red inequalities, so those are the things that are determining, those are the determining factors, that y has to be less than this or y has to be greater than that. And we know that the maximum profit is $200 because they've told us this. They tell us that the maximum profit is occurring at 4,4, at the point 4,4. Well, point 4,4 is one of the corner points. All right. So how do I determine? So I was told in this. Okay. So this isn't exactly a real problem, but I was told here that the maximum profit of this equation, 20x plus 30y, is maximized when we have point 4,4 And the maximum profit that's made is 200. So how does that come about? What's basically being done is you're getting the profit, which is equal to 20x plus 30y, and you are substituting in the corresponding values of x and y from each corner point. So I'll pick negative 1 and 4 first. So if I choose negative 1 and 4, well, my maximum profit would have to be 20 times the x, which is negative 1, plus 30 times the value of y, which is 4, and when I add that up, I end up getting $100, because 120 minus 20 is 100. So I know that my maximum profit using this point, negative 1 and 4, is 100. So that definitely is not the point that I'm looking at. We know the point already is at 44, but I'm just showing you that when we go to 0.44 now, let's do 0.44 next, I do P, the profit, is equal to 20 times 4 plus 30 times 4, and that ends up giving me 80 plus 120, which is 200. There's my maximum profit. And if I put in the third point, just for the sake of being consistent, if I put in 2/3 and 7/3 for the third point, then I end up getting the profit is equal to 20 times 2/3 plus 30 times 7/3. Okay, and therefore we end up getting something that like 40 over 3 plus 210 over 3, which gives me 250 over 3. 250 over 3 is really going to be just a little bit more than $80. It'll be, when I divide that, it's just approximately 80 something. It'll be $82, 83, something like that. Approximately 80 to 84 or $85. Okay? So therefore, that's definitely not going to be a possible solution for the maximum profit. So given the three constraints, and we know that our corner points are these, negative 1, 4, 4, 4, and 2/3 and 7/3. Then what we do is we replace those values in the profit function, the values of x and y, and whichever one maximizes or gives me the highest price or the highest amount, then I know that's my maximum profit. And we said that it has to be in the corner points. Okay, so when given a feasible region in the yellow area, the corner points are always going to be the ones that give us the best solution, or one of those corner points, and then you have to test out each of those points. Okay, so we have another question here where they've given you, it says, in the manufacturing of compact discs and laser discs, a company's expenses are described by the following system of inequalities. And they're given x is greater than or equal to 0, y is greater than or equal to 0, x is less than or equal to 3/2 x plus 12, y is less than or equal to negative 10x plus 150. So all of that has been graphed for you now. Okay? And we are told that the company's profits are given by this equation, P is equal to 7x plus 5y. And they want you to find the company's maximum profit. So your first step, given the graph, is to find the four corner points of the feasible region. Because this is the feasible region, the yellow part is your feasible region. That has already been done in this case. You didn't have to figure this out on your own yet, but you will. We'll do an example in a couple of minutes where you're going to have to do everything. But what you'll do is, in this case, you've got the feasible region already colored in, and we see that the 4 corner points are found, so we can start naming at least 3 of the 4 corner points. So one corner point is found at 0, 0. Another corner point is found at 0, 12. A third corner point is found at 15, 0. And the fourth one is yet to be seen because it's not very clear. But when we use substitution, and we use the 2 equations, y is less than 3/2 x plus 12, and y is less than or equal to negative 10x plus 150. So those 2 equations will give me the 4th corner point that I'm looking for. Okay, we figure it out to be using substitution or elimination, whichever one you prefer. You find the point to be at the end 12 and 30. So that's your 4th point, 12 and 30. Okay, and what you do last is you take all 4 of those points. So all four of those points, 0, 0, 0, 12, 12, 30, and 15 and 0, and you insert them inside, you insert them in the profit function 7x plus 5y, where this obviously is your x value, and this is your y value. This is your x, this is your y, and so forth. And you replace those in there and then you look to see what the result is. Since 7 times 12 plus 5 times 30, so the points 12 and 30, since that point seems to be giving us the highest result in terms of profit, then we know that the corner point 1230 is where we have the highest profit. And so therefore the highest profit is going to be at 234. So the question was asking, find the company's maximum profit. Because that was the highest number of the four points, it gave us 234. Then we know the profit is maximized when x equals 12 and y equals 15. Okay, we're going to do one example from scratch. Okay, we're going to start it like right from the beginning, and then we'll do one more question in class the next time I see you, because I think it's important that we do this step by step also together in class so that you guys can answer questions. You can ask questions. I'll answer the questions. Okay. So here's our here's our graph. So there's my 1, 1, 0, and we know that this is the y-axis. There's my x-axis. So that I think I'm going to have to lower this a little bit because unfortunately it's going all the way up to 14. So I want it to go high enough. Okay, so I'm going to put this here, and I'm going to put this down here like that so that we can get a good graph. Okay, so I take a look, I say this is 1, this is 1, there's my 0, there's my x and y axes. So my first graph has to be that y is less than or equal to 14. So I do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that I know first line I will make in pink so that I've got less than or equal to 14. So this is my y is less than or equal to 14. Okay, and as a result of that, less than or equal to 14 means that I am, I'm going to go a little bit there, means that I am, I'm going to go a little bit there. So less than or equal to 14 is all under here. Okay, there's my less than or equal to 14. Then my next graph we'll make blue, and the next graph is y is greater than or equal to 1/2 plus 2. So 1/2 plus 2 tells me that I have 2 is my y-intercept, and I go up 1 and 2 to the right, up 1 and 2 to the right, up 1 and 2 to the right. So I'm going to graph that now so that I have my line that is somewhere. Nope, I don't like that. I'll put it, nope, I don't like that either. Absolutely not. There we go, that's much better. Not perfect, but it gets it going. So y is greater than or equal to, we've got y is greater than or equal to, so it's y is greater than or equal to 1/2 x plus 2. This is at 0, 2. So that I'm going to have, when I shade it in, I'll go to the blue. It has to be larger than that, so it's going to get shaded above. Okay. It gets shaded above. And then the last one I need to do is going to be that x has to be greater than or equal to 1. Okay. X has to be greater than or equal to 1, and we'll do that in black. So x has to be greater than or equal to 1. So greater than or equal to 1 means that I have a vertical line So x is greater than or equal to 1, and I will shade that in with green, I suppose. Greater than or equal to 1, let's see. So it's here. So this is my area right here. Greater than or equal to 1. Alright. And I think I need to shade this part in. Oops. Okay. So this is greater than or equal to 1. Alright. Now, what I need to do is I need to stretch out this graph a little bit more. Oops. Oops. So that. Okay, then my blue graph, I need to stretch that out a little bit more so that we can see it a little bit better. Okay. And the last one is right there. So we've got green, we should be set now. Okay, so we take a look at where the overlapping is occurring. Alright, so I see a point here. So where's the overlapping occurring? We're going to shade in the area that's common to all three of the graphs. And that area seems to be this orange portion that I am coloring in right now. Okay, so there's my shaded in area. Alright, now given this information now, we know where the shaded area is. We're going to look for our corner points. Okay, so I'm just going to get rid of some of this extra color all around because it's just making more of a problem right now for us than we need. Okay, so we're going to get rid of some of the color. Okay, and we can get rid of some of that, and we can get rid of all of this all around. We don't really need it, just to take away a bit of confusion. Okay, so we know that the shaded area is right there, and that means that our corner points are found here in black. Here's the next corner point, and there is our third corner point. Alright, now, generally speaking, our graphs are usually quite precise. I can't really get it that precise on the whiteboard here when I am on the InterWrite workspace when I am making the lines automatically. So I'm going to do my best, but it's not guaranteed. Alright, so I start looking for my first corner point. It would seem to me that my first corner point, again, keeping in mind that this line was not done perfectly, it would seem to me that the first corner point is found at 1 and 3. So I'm going to write 1 and 3 is one of my corner points. 1 and 3 is one of the corner points. I look at the next one and I say 1 and 14. So 1 and 14 seems to be the other corner point. Okay. 1 and 14 is also 1. And then my third one appears to be, so if I stretch this along, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, and 14. So it seems to be at 26 and 14. Okay, and the other point is found at 26 and 14. Alright, so given the shaded region being all there, and we know that the corner points are the ones where the profit is maximized, then I can take each of these now, each of these points, so P is equal to 5x plus 4y, and I can replace it with, starting with the first one, 5 times 1 plus 4 times 3, which is definitely not going to give me the maximum profit, so 5 plus 12 gives me 4 plus 5, 12 plus 5 equals $17. So that's definitely not going to give me the maximum. If I do the next one, P is equal to 5x plus 4y, and I'm going to use x as being 1 and y is 4 times 14, well, I end up getting that we've got 54. So 4 times 16, 50 is not 54, is 56. So I've got 4 times 14 is 56. 56 plus 5 will give me a maximum profit of $61. And I think it goes without saying that if I do 5 times 26 plus 4 times 14, then I am definitely going to have a number that's far greater than the other two, so that I will have so that equals, when you multiply these out, it equals $186. All right, so between the three functions then that we have, the three corner points, the one that has given us the maximum profit, then therefore the maximum profit ends up being $186. And it's $186, and it's found at the corner point of 26 and 14. Okay. Now, we don't know what all of this means at this point. I mean, what do we mean at 26 and 14? What is it referring to? Is it referring to we're not given anything there that explains to us what the point 2614 means. So that it's something that we're going to be looking at further in the next lesson. All right, see you next time. Thanks.